This is the first section of a short video that I'm going to be making about buzz coils. The one on the left is a design developed by J.B. Castaños down in Louisiana, and very effective. I call it the lightning bolt maker, and you'll see how much different it is. The one in the middle is one that I put together, and the details of it can be found on the oldmarineengine.com website. And then finally, this old fella here, it's certainly a nice looking piece of woodworking, cabinet making. It's a Michigan model made by the Detroit Coil Company, and it has the traditional, I guess what you would call the contacts for the interrupter. And I'm going to be demonstrating how powerful the various sparks are, and also I will be measuring the amount of current that they're going to be drawing. And I'm going to be using these two ammeters. The one on the left is a little bit more sensitive. Its full scale is approximately 1 amp, and the one in the middle here, its full scale will be 2 amps or 10 amps. So it'll be deflecting to the right. So 50 on that scale will be either 10 amps or 2 amps. So, and the voltmeter is an analog voltmeter. The reason why I'm using analog meters here is that if there is any effects of interrupted DC current, these meters will actually smooth out the variations and give a kind of an average reading, so that it'll be reasonable to make some sort of valid comparison. So let's get started. I'll be doing the Michigan coil first. So here we are, the first test. You can see that we've got on that voltmeter, full scale would be 25 volts on that scale. So we've got 12.5 volts off this battery. Going from the positive lead, we go through the ammeter, and that'll give us an indication of the current that's being drawn. I will, as a switch, I will touch this terminal to the negative lead here, and that'll complete the circuit. There's the coil, there's the high tension over here, and what I've done is rig up a small lamp, and you'll see glow coming off that bulb. When I see it, it'll be sort of an orangey kind of a glow. And what I'll do is shield it from the overhead light so that you'll be able to see it. Okay, well this coil, and I'll take the lid off these in just a second, but you can see this one's got an on-off switch. But for the purposes of this video, I'm just going to repeat what I did before. You can see we still have 12 volts off the battery, same ammeter, and same little testing gizmo. But when you see what happens, and you can see that the needle is being pinned there. We can see we're taking just well over an amp plus. So that's J.B. Castaños coil. Now, the interesting observation here is you get a lot more kick off that, but you also take a lot more juice, more than twice the juice or the current off the same voltage. So you've got 4 times the power, because if you double the current, you quadruple the power. It's a function of the square of the current. So for show purposes, this coil is fine. If you're on a long boat trip, just make sure you have a huge battery. We'll come back to this in just a second. I'll get a different ammeter so we can get a more accurate reading on the current. Now you can hear the buzzing of the coil, and I'm trying to, as you can see the little spark, you can see this ammeter is reading about half scale, so it's around half an amp. We've still got 12 volts on the and I'm trying to get that purpley streamer. That gives you some idea of what this coil is doing in terms of the intensity of spark coming off that coil. So that gives you that's the step number one, coil number one. And let me see if I can get in there a bit. I don't want to get too close, but I'll get zapped. But hopefully you can see that. Here's coil number two. This is the one that was described on oldmarineengine.com. And you can see we've got just about the same amount of current. And we have the 12 volts. And here we go. We're trying to have a look at the spark that's being produced by the coil. And again, trying to get in there without getting zapped and trying to give you some indication of what that streamer might be like. It's not dissimilar. It's a little better, but it's a little hard to see. But there, I'm trying to get it, and you can see that it's a nice orange streamer in there. A lot of reflections going on. And again, the current being drawn is actually a little bit less than the previous one. So that gives you an indication of what that one is doing. Certainly these coils are enough to throw a good healthy spark. So here we are back again with the story about the coils. This first coil is the traditional one. I'm going to hold it up to the light, and you can see that it has the usual sort of a trembler assembly with the brass knob that will let you actually adjust as the points wear out. That brass adjusting knob is right there, and you tweak that back and forth, and you can see that great big sort of pill there. That helps the magnet pull the contacts open. The problem is it does represent a lot of inertia to get moving, so the frequency of buzzing, if you recall, was a little bit lower. Moving on to the next one, this is the one that's described in oldmarineengine.com. This is the ignition coil, and this assembly in here is the buzz coil, or the trembler part, and you can see that the green is the coil. This is the fulcrum attachment, but this is the set screw that will adjust the amount of tension that you have on the spring. That arm actually could be a lot shorter, but it's what I had. It's actually a set of old points from I think it was from a lawnmower or something. You can see the capacitor there. It's fairly straightforward and simple, mounted on a phenolic board. And then finally, moving on to JB's version, you can see the relay that he recommends. The capacitor is there, and then the ignition coil with the high voltage lead, nice high voltage lead going out there to the contact. The essential difference between these two and JB's is that the trembler coil, which is to say this section in here, is actually in series with the primary winding of the ignition coil. With JB's, and that's one of the reasons why it's so powerful, is that the coil inside that relay is in fact in parallel with the primary of the ignition coil, plus the fact that the mechanical arrangements in the relay are much smaller and give you a much higher frequency, so that the rate of change of current going from on to off, because it's buzzing at such a much higher frequency, the rate of change of current from on to off is much higher, and therefore yields the higher voltage. But again, you see the price that you pay is quadruple the power consumed. So there you have my story of